MCQ 27 is an electrolysis question. So we need to be able to choose the correct water-based equation. So let's take a look over at the right side. First, we have hydrogen as well as water. So for this equation here, we're looking at the pairing of either the H2O, H2 half equation that give us an E value of negative 0.83 volt. So writing out fully, there will be 2 water plus 2 electrons reversibly to produce hydrogen gas, as well as 2 units of hydroxide. Now another version would be to go with the H plus and the H2 half equation, and that is 0.00 volt and written out as 2H plus 2 electrons reversibly to give us hydrogen gas. Now we are to go with this equation over here because the bottom one should only be selected if conditions are acidic. Now in the blue side here we have oxygen gas, and this is in the presence of sodium hydroxide, and this is again going to be paired with water as well. So we have two forms of equation, either the water oxygen half equation. That water oxygen half equation will be at an E value of positive 1.23 volt. From the data booklet, we'll be writing out as O2 plus 4H plus 4 electrons reversibly to give us our 2 units of water. So another version will be us going with the hydroxide O2 version, and this comes with an E value of positive 0.4 volts. So from the data booklet, it will be given out as O2 plus 4 electrons plus 2 units of water reversibly from 4 moles of hydroxide. So we should be using the second case over here rather than the first case, because this is to be used if conditions are considered the basic or alkaline, and the presence of sodium hydroxide dictates that this was a basic situation here. And with that, we can see that the E naught of the oxygen electrode will be at 0.4 volts. So that part is being settled. So you can see that the blue color segment is oxidation. We are going to lose electrons. And for the yellow color segment, the hydrogen portion of this hydrogen fuel cell is going to go through a reduction process, and that's through the act of gaining electrons. So the flow of electrons will be from the oxidation electrode towards the reduction electrode, and in this case here, where oxygen is entering is electrode Y, and where hydrogen is entering is at electrode X. We're going to see the flow of electrons from Y to X. So the answer will be C.